And I'll share my screen. We'll do a quick introduction.
Okay, welcome everybody to the last N3C Community Forum of 2022. Next slide, please. As always, presentation will be recorded, and post your questions through the Q&A or chat button. And our featured speaker is Sean O'Neill, and he'll be, he's waving, he'll be talking about exporting code to GitHub from the Enclave. Next slide, please. So next year's presentations, not all of, just two next year's presentations, metformin associated with less severe COVID-19, N3C analyses and how they informed a phase 3 trial by Justin Reese and Carolyn Bramante on the 9th of January. And I see we have a nice snow picture. That's very, very nice. And January 23rd, collaborative cohort of cohorts for COVID-19 research. Elizabeth Olsner will be talking about that with a break in between. Next slide, please. Okay, so Sean, I think it's over to you. Exporting code from the Enclave to GitHub, tips and tools presentation.
Thanks, Joel. So it'll be, I think, probably pretty quick and a little bit technical today. So I'm going to share my screen. We're going to try and do this as a demo. So, you know, imagine that you are a N3C related researcher and you have done some really cool work. You've written some code in code workbooks or maybe a code repo, and you want to put it up on GitHub so that other people can browse it. This is actually not too hard, though there are a couple of small complications that you'll need to be aware of. The first thing before we go any further is I should mention that although it's possible to export your code from the Enclave without really any review, rather, I should say it is possible to export your code from the Enclave without really any review, because code has been determined as being safe enough to do that. You do want to make sure that you sort of scan through your code and make sure you haven't hard-coded any identifiers or information that shouldn't leave without a data review. And probably the most common thing that people will hard-code into their code that shouldn't leave is like a site ID, you know. So if you're explicitly encoding that you don't want data from site 732 or something, go in and edit the code for that before you do the export and give it some random identifier, and then go back in and put it back in your real identifier or something of that nature. So it's just a good idea to be mindful about the things that we want to export from the Enclave or not. Can everyone see my screen okay? If I type echo hi there, you can see it?
Yeah.
Cool. All right. So exporting a code workbook, as I said, is not too difficult. If you're working in a workbook like this, it's a pretty easy thing to do. All you have to do is go to the little gear icon here and say export Git repository. Just in case I did that too fast, it's right there. And that'll open up a new tab. And by the way, I'm sort of assuming here that if you're interested in doing this, you're familiar with using Git, especially using Git on the command line, because what is given to you when you sort of choose to export it as a Git repository, it opens it in a new tab with this new panel over here on the right, and it actually gives you the command to run to clone the repository. Now, this particular command includes some secret key information about my account. So I'm going to copy it and actually just run it off screen. There we go. Okay, so I copied it and I pasted it into my terminal, and it says git clone, and it's like a really long URL, which has a secret key in it. And then I'll clear my screen. Okay, so now I'm back. So I didn't want you all to see my secret key information so that you could start cloning all my stuff. But now that I've done this, I've got workbook 1 and it's right there. Now, one of the complications of this is that what you get out when you do a Git export from a code workbook is it's not the cleanest and most easy to read and view. But we'll see how we can, what we're working on to start cleaning that up. So all the R code is going to be present in a pipeline.r file. All the Python code is going to be present in pipeline.py, SQL is in pipeline.sql. And then there's a YAML file, which provides some metadata that really isn't all that useful for me as a researcher. Now you might be asking, well, can I actually edit this Git repo on my local machine and then push the changes back up to the Enclave? You know, can I use my own personal editor to do this? And the answer is no, you can't do that with code workbooks at least. So really, this is only going to be something that we're gonna, if we wanna make changes in the code workbook, we can pull it down and then we can push anything that we want up to GitHub. So that's what we're gonna do next. So if I go to my GitHub account here, I can go to repositories and I can create a new repository in GitHub. And I'm going to call it the same name as my code workbook. You maybe don't have to do that, but having multiple GitHub repositories with different names referencing the same thing can get hairy, so I wouldn't change anything like that. And then I'm going to create my repository. So this gives me, if you're familiar with GitHub, it sort of gives me the ability to push an existing repository from the command line. And this is almost what we want to do here. But the trick is, I want to make the repository that I pull from, which is the one that's listed here, as a read-only. So I only want to pull down changes from the Enclave, and I only want to push to GitHub. So the command to do that is actually a slight bit different. What I'm going to say, and I have it written down on the side here because I can't remember a git command to save my life. Git remote set URL --add --push origin, and then the URL that this gives me. So what this says is when I go to push this particular repo from my local computer, it'll push only up to GitHub. And when I pull, it won't be pulling from the GitHub version. It'll only pull from the other version of the Enclave. So now that I've done that, I can do a git push. And my information has been pushed up to GitHub. And so if I go back into my workbook 1, I can now see my pipeline.r, pipeline.py, pipeline. So on and so forth. So as you're going along, let's suppose that I make some change to my code. I can close out this one now because I don't need that URL anymore. Maybe I'll go in here and I will say new comment, exclamation point. Now I've made that change to my code, but what's sort of, and I've discovered this through via trial and error, is that that change in my code won't be committed to the repo in the Enclave unless I do something to actually trigger it. And just editing some code doesn't do it. The things that do it are creating a new transform, probably deleting a transform, though I haven't actually tested that, and running a transform. So what I will do is I will just run this transform. It doesn't even have to complete all the way. I just really want to run it to trigger that change to be committed to the repo that exists in the Enclave so that I can pull that change back down. So I'll click on run. I'll cancel it because I don't really care that it actually runs. I just wanted that code to be pulled, to be committed. And now down here on my local repo, if I were to look at, let's see, that was an SQL. So if I look at the pipeline.sql file, here's that last transform, and it doesn't have my new comment at the bottom. But if I do git pull, it pulls in that one change. And now I see my new comment there. Now, since I've previously set my GitHub repo to be a push-only GitHub repo, I can say git push, and that change will be pushed up to GitHub like so. And now I just see this particular update right now. It's a bit strange to me that my GitHub repo is saying that this was edited 8 months ago. I think that's because I had this as a previous repo in GitHub and then I deleted it and I just recreated it. That looks like a GitHub bug. Okay, so that's the basic story there, with taking a workbook and pulling it down and then pushing it up to GitHub. And you can sort of do that as you work along. You can also do branches. So if you're not familiar with branches in the Enclave, I'd recommend that you do, because it's a very cool way, especially in code workbooks, to run different experiments. You know, you have an experiment and then you run another one where you sort of modify a parameter, and then you run another one where you sort of modify a parameter. Creating branches of these things is a nice way to keep those separate and keep all of your results for each experiment as well. So in this case, I've got a branch here and I'm on my example branch. And that one doesn't have my comment down here, but I can say now on example branch. And again, to get that particular change to commit in this branch, I'll quickly run a transform or do something that triggers that. And then down here, you'll notice I'm still on my master branch. And if I do git branch, it says that there's only a master branch that it knows about. So the usual way that you do this in Git is if your remote has multiple branches and you want to see those locally, you do a git fetch. And by the way, I'm talking here like I'm some kind of Git expert, and I am not. But now if I list my branches, oops, it doesn't even show me that one. But it does know that we have this other new example branch remotely. And so I can switch to that branch by saying git switch example branch. And now I'm on example branch and I see that and my master. And if I again do a git push, there's not really much to it. I just do a git push and that branch will also make its way up to GitHub under a new branch here, example branch. So you can work with branches as well in GitHub. All right, so that's one thing there. I'll just briefly show it for code repos as well. It works pretty much the same way. If you're not familiar with code repos, these are a little bit more of a traditional developer-like experience for working with code in the Enclave. They only support Python and SQL. But you do get to write sort of your Python code, and you use transforms very much like in workbooks as well. So in the Enclave, transform and the data set that it creates are very tightly bound. And so in much the same way, if I were to make a change here, I can commit that change. And so unlike in code workbooks, we explicitly commit our changes in the Enclave. And then I could click build to actually build the data set that this creates. But what I'm really interested in is cloning. And so here I can get that URL and I can copy it. And again, I would say I have to add the git clone myself. So I'd say git clone and then paste in that long URL. And after that, everything would more or less work the same. You can similarly have branches in code repos, and you can do the same trick with a code repo to fetch your remote branches and then switch to them to see them. And again, you can also do this push trick so that you are pulling stuff from the Enclave and pushing up to GitHub. All right. So with all that said, I'm just curious if anyone has any questions thus far. And if not, I want to show a little utility that I'm working on as part of logic liaisons to hopefully make this a little bit nicer.
Yeah, this is great. And any questions?
All right.
Okay.
So if we go and look at, so one of the nice things, I guess, about code repos is that you get sort of a nice file structure and you can organize your code in a way that makes sense to you. When you export a code workbook, what you get out are just these pipeline files. And they're not all that user-friendly. So for example, what you get is this transform pandas thing that's always going to be there. And you can tell which data set it writes by its resource ID, they call it in the Enclave. And you can tell what data sets it reads by its resource ID. And then for every one of your transforms, and then you sort of see the code that's part of your transform. And you sort of get these all just dumped together into one SQL file. So if somebody were to send me this repo as part of like a code review or something, I wouldn't be all that happy with it, because I'd be having to figure out, sort of trace around what goes to where and what goes to where. What I've been working on is something I'm calling the N3C workbook parser. And it currently lives in this repo that I have on GitHub here. So let me hide this. And the nice thing about this is that it not only parses out the transforms that are in these individual files, it also allows you to combine multiple code workbooks into one. So if you're used to working in the Enclave, sometimes you do your whole analysis all in one code workbook, but I often break them up into multiple code workbooks, right? Like I have one that does my sort of data munging, I have another that runs my model, I have another one that sort of evaluates my model, and then I have another one that sort of does the final plots and things like that to create the output. So this tool is made to work with multiple code workbooks. I'm also hoping to integrate parsing of code repositories into it, but I haven't done that yet. It's going to require a little bit more finagling of the files. But what it gives you is a folder that has all of your different transforms. And let me show you that in my it gives you a folder in one of your somewhere that has all of your different transforms as a separate file. That's one nice thing. And the reason I've added .text to the end of them is it makes it easier for me to open these files in my browser to look at the code, as opposed to if I tried to open this SQL file in my browser, it would prompt me to save it when I've already got it saved. The other kind of cool thing it does is it generates this sort of like computation graph of what goes on in your workbooks. And this is the transforms, not just in one code workbook, but of multiple code workbooks and how they connect together. The other thing that it does is it creates an HTML page where this HTML page could be put on GitHub as a GitHub pages, where this particular pipeline, you can actually sort of hover over each one and see a little bit of description about what it does. They're colored according to, by default, the file extension, so SQL, Pi, or R. And you can also customize things too. So you can say, you know what, I want this particular node to be a different color and a larger font size and a different shape. You can do that as well. And you can click on one of these, and in a new tab, it'll actually open up the code from that particular transform. And so the instructions on how to use this are in this particular repo. It's a brand new tool, and I'm hoping that some other people can help make it a little bit more user-friendly. Partially, it's not super user-friendly because there's just multiple Git repositories in play, right? If I'm working with multiple workbooks, those are going to be pulled down as multiple Git repositories. And then I have the Git repository that I want to put on GitHub. So I've got at least 3 in play. Mixing multiple Git repositories gets messy, nevertheless. The way it works is each transform in your code workbook, you can create a sort of metadata block, which I've just designed as a code block with a special star character at the end of each comment. And you define it as YAML. And this is sort of saying, hey, this is the input concept members transform. It will be an SQL. The description is it just returns the concept set members input. And then there's an input section where you can list the other inputs that are a part of it. Here's an example of an R transform that has most of the same information, That's got inputs, the extension, a description, and then you can also customize some of those properties of the of that particular transform when it shows up in the node. And this is all based on GraphViz, so you can customize pretty much any property that GraphViz can work with. The parser is a little bit fragile, so don't get too fancy with that. But that's more or less what it does. And then you run the parser on a directory. So you run this workbook parser and you tell it which directory to look for workbooks in. So you could actually have a number of code workbook subdirectories that you search that are created. And then you tell it where to create the output, and it'll create the output. And then you can take this output and spin it up to GitHub so that other people can browse it. So for example, this is the sort of browsable view of it. And then I could go to my GitHub page to browse the actual code in a nice, somewhat parsed manner in my example project. So that's about it. Exporting to GitHub is a nice way to get code pushed out into the outside of the Enclave for code review, because the Enclave is a fairly proprietary platform. Even though it's backed by Apache Spark, it's going to be difficult for other people to run that code. But with a little bit of parsing, they can at least sort of browse through it and see if that all looks copacetic to them.
Excellent. Well, that's fantastic. Eileen Keck wants to know, can someone you were working with fork it and use it for version management?
Forking is certainly welcome. Pull requests are welcome. I'm not clear on what you mean by using it for version management.
I'm not sure either, actually. Eileen, are you a analyst? I guess not.
I can unmute Eileen, maybe.
Great. Okay.
Hi, Eileen.
Hi, can you hear me?
I can.
Okay, great. I was going to ask, if you have a group, say, working on the same code, and they're working on, say, different transforms, and they want to know as a group where they are, could you use this to understand that? You know what I'm saying? Like you would use it for version management in your own group?
You could, like I said, it gets kind of complicated. So each workbook could, in theory, have a different branch. So maybe like I'm working on master of my code workbooks, but a colleague has created themselves branches of my code workbooks, right? And so what I would probably do is pull both of those down, including both of the branches in the code workbooks. Mm-hmm. And then in those, check out the master and then point my parser at it. So you can parse out the master and create an output folder that would itself be a GitHub repo. And then I can create a new branch in that output folder, and I can check out the other branches over here, run the parser on it, and then point it at the output over there. So it's a little bit manual, but yes, you can sort of take branches and create branches and make those changes in the parsed output look like what you want. And then push those branches up, and you get all the sort of goodness of Git when you do that.
Even to understand what they're doing, this is beautiful. Thank you.
Yeah. Mm-hmm. Oh, you're welcome.
Thanks. Other questions? I have a question that's broader, and you may not know the answer to this, but you probably do. Do you have any sense as to what fraction of code, say in the knowledge store, has been exported?
I don't have any sense of it, no. And potentially this is something that could make it a little bit more easy, make it a little bit easier to export and cite. I mean, that's one thing that I've been sort of hoping for in terms of knowledge store development, is to be able to use things there and then cite them, so I don't have to include all the methods or something from an included thing in my own publication. Right.
Well, and another really, I think, major application is essentially reusing the code for institutional or smaller different consortia efforts, which it would be actually a tremendous service to the community if we were to embark in some sort of a systematic export and porting of sort of select codes. I know you're working on a bunch of educational efforts, including a book that I've been remiss in helping you guys with. And it would seem to me that at some point, maybe probably in the next year, sort of thinking through, okay, which pieces of code would be of general interest, both to the COVID and the broader communities. And I mean, obviously individual groups can do this on their own, but does it make sense to do this in a sort of more centralized way? Do you have any thoughts about that?
No, I would definitely like to see that sort of thing happen. A lot of what I was just on a call earlier, and someone, I think maybe it was Johanna, made sort of the comment that, you know, we actually are doing a lot of work that would be well aligned with the larger OMOP community, but because we're doing it in this sort of different proprietary interface, it's not directly applicable without some backtracking of the code. And so being able to parse it out and present it in a more readable fashion, I think would definitely help in reverse engineering some of the really cool algorithms that have been developed in N3C, but made useful in the wider OMOP contexts or EHR context in general.
Right, absolutely. Well, cool. This was great. It was wonderful year-end demo and description. That's extremely valuable. I think that'll.
Joel, can I say something?
Go ahead. Yeah.
Well, first, Sean, thanks so much for the presentation, and it really, as always, with all the material. But on that note, there are changes happening soonish, where Foundry is enabling the use of either RStudio or Jupyter Hub, with essentially being able to use as the IDE and go into Foundry. And again, we've rolled that out on the intramural portion, because we have an instance obviously for N3C and then a shared instance for NCATS and NCI. We're just rolling that out. So I do think, Sean, it'd be great to have a conversation with you when we enable that on N3C, because we have to figure out exactly how someone's going to work, especially with regards to the download policy. You know, that's part of the tricky piece, is once you have access to an IDE, it's very difficult to figure out how you can keep things, you know, within the environment. So, but that being said, to your point, Sean, about what you have to do to work with the OMOP community, we think that'll be areas that'll make it a little bit easier, you know, without having to do some of these transformations. So there's more work coming in this front. And given that this is the last meeting of this year, I also want to thank, you know, Sean, you know, Joel, and the entire community, you know, for the continued support and use of this platform. You know, we're always trying to make it better, but it's not worth anything if we don't have the users like you guys. So I just want to let you guys know, especially from the NCAT side, we truly appreciate your work and your effort on using this and also making it better.
Right. Well, we all appreciate support from NCATS and NIH. Obviously, none of this would happen without you guys.
Thanks for paying the cloud bill.
And for great collaboration. No, it's an unusually collaborative group between program and researchers.
I also just want to reiterate that code export is not really restricted, and that's because it's really hard to get row-level patient data into the actual code itself. Code reads data. Data itself doesn't generally write into code. And so it's pretty easy to do these Git exports. Like I said, you just want to check around for things that you've hard-coded into your code that might be sensitive.
Great. All right, Sean, thank you. And thanks everybody for a great year, and we'll see you next year. Thanks. Take care.
Thank you.
Happy holidays all.
Happy holidays.